One of the cool features of the SureServo2 system is it can be set up as an absolute positioning system that keeps track of the encoder position even when there's no power applied to the servo system. It uses the exact same drive and motor, except we add a small battery box that maintains the encoder position during a power outage. All SureServo2 encoder cables have this little connector on them, so you just plug the battery box in there. There are a couple things you need to know how to set it up, so let's walk through it. We need to install the battery pack and learn a neat trick for replacing the battery. Determine the home position of the absolute coordinate system. We can do that using any of the built-in homing methods, using digital inputs, or via parameters. Learn how to use absolute coordinates with a special eye on the limits of absolute positioning, and review a list of things you need to be aware of. Here we go. This is the battery box. Since all SureServo2 encoder cables have the battery connection built in near the drive end of the encoder cable, you just open the battery box, loosen the screw, and clamp the encoder cable in here. I like to do that first because it holds the battery box in place while I'm working on it. Plug the cable connector in here in connector J2. Now make sure you're plugging it into this J2 connector. That might not be obvious if you don't have a battery plugged in yet. Close up the battery box and you're ready to go. Now when it comes time to change the battery out, here's a little trick that'll save you time and ensure that you maintain the absolute positioning data. Open your new battery box and remove the battery. Then open the existing battery box and swap batteries. This capacitor will hold the voltage for a while. I think the manual says 10 minutes. But if you can, replace the battery while the system's powered. That'll ensure that you don't lose the motor position regardless of the state of the battery. Close up the battery box and you're good to go. This also saves you the time of uninstalling and reinstalling the cable clamp and possibly installing the encoder cable in the wrong socket. Now, how do you know when it's time to replace the battery? The drive will issue an AL61 or possibly an AL6A alarm when the voltage is low. If the battery voltage falls below 2.7 volts, you might lose your motor's position. The low battery alarm occurs at 3.1 volts, so that's your best indication it's time to replace the battery. Beware though, this is a lithium battery. Unlike alkaline batteries, which slowly degrade, once the lithium batteries start to go, they go quickly. So don't put off changing that battery when you get one of those low battery alarms. Next, we need to set up the home position of our absolute positioning system. Of course, absolute positioning only makes sense when you're in position register mode. You don't have an absolute position in speed, torque, or even pulse terminal modes. So I'll go to parameter 1.01 and set it to a 1 to change the drive to position register mode. And the drive reminds us to do a power cycle. It's really important to remember to power cycle the drive after any mode change. If things don't work, it's usually because you forgot to do that power cycle. In position register mode, you can always execute a homing path to use one of the built-in homing procedures. There's a whole video on how to do that, so we won't spend time on it here, but it's this guy in the free SureServo2 Pro software where you can see all the homing options. The nice thing about the built-in homing is you can have the drive find the home position for you, which means you don't need an external controller to run absolute positioning. If you are using an external controller, then you have 3 options for finding the home position. You can trigger this homing path remotely by writing a 0 to parameter 5.007 and let the drive find the home position using one of the built-in homing routines. Again, see this video to learn about those. You can use digital IOs to mark where home is, or you can read and write parameters via any of the available communications methods. To use the digital IOs, first you need to tell the drive you want to use it in absolute positioning mode by setting the lower digit of parameter 2.69 to a 1. And the drive reminds us to power cycle the drive for that to take effect. Remember, you always need to power cycle the drive after a mode change. I'll do that, and we get an alarm code of 6A. Alarm 6A reminds us that the absolute position has been lost either due to loss of battery power or, in this case, we haven't set it up yet. So let's set that up using a digital I/O method. Now instead of wiring up a controller or even toggle switches, let's use the free SureServo2 Pro software to simply force digital inputs. You can download a fully functional free version of the SureServo2 Pro software at AutomationDirect.com. I'll connect to the drive, and let me adjust the window so you can see everything, and read the system info so you can see what hardware I'm using. I'll also read the drive parameters into the workspace. Bring up the digital I/O dialog. Looks like digital inputs 9 and 10 aren't used, so we could use those, but Instead, let's use the virtual inputs. Enable editing. Select input 11 and change it to the absolute coordinate system enable. A means it's a form A, or normally open contact, which is what we want. Hit OK, accept that change. Select input 12 and change it to be the coordinate system clear bit. That clears the encoder and user pulse counts to set the new home position. And again, we want the A, or normally open contact, so I'll hit OK to accept that. Disable editing and click these checkboxes to enable software control of those bits. Click this guy to enable the absolute coordinates, and when I click this guy to set the home position, we see the absolute position alarm goes away. I'll bring up the user pulse count and rotate the encoder one full rotation. Now remember, the SureServo2 Drive defaults to 100,000 pulses per revolution, and sure enough, if I press the left arrow key to see the upper half of this 32-bit number, yep, we're at 100,000. Press the left arrow again to go back to the bottom digits, and some change. I'll move that back to roughly halfway and power down the drive. Reapply power, bring back up the user pulses, and sure enough, the encoder count was maintained through the power cycle. Cool. Let's power down again, and this time move the encoder an additional roughly quarter turn while the drive is powered down. Power back up, bring back up the user pulse count, and yep, exactly what we expected. The encoder kept track of its position even though the drive wasn't powered. Perfect. If I reconnect to the drive and enable access to the absolute coordinate system, then set the clear bit, the absolute coordinates get reset to 0. Perfect. Okay, let's disable the virtual I/O and see how to enable the absolute coordinates via parameters. I'll rotate the encoder to get a non-zero encoder count. First, set parameter 2.069 to a 1, just like we did for the digital I/O. That enables the absolute system. Now, we already did that in the previous example, so we don't need to do it again. Next, we go to parameter 2.71 and set it to a 1 to set the home position. Oops, the drive reminds us that that parameter is locked. So we go to parameter 2.08 and set it to a 271 to enable parameter 2.71. And it tells us we unlocked parameter 2.71. Now if we go to parameter 2.71 and set it to a 1, we didn't get the locked message, that's a good sign, and get back to the pulse display, yep, we're at 0. If I rotate the shaft, then go to parameter 2.71 to try and clear that home position again, nope. You have to unlock parameter 2.71 each time you use it. That helps ensure you can't accidentally reset the home position while the system's running. Do you have to reset the home position to 0? Nope. When you reset the home position, it actually uses a value that's stored in parameter 6.001. That defaults to 0, which explains why we got 0 in our demos, but if you need an offset when you mark the home position, well, put it in parameter 6.001. That was a quick intro to using the absolute encoder system. Chapter 10 of the user manual walks you through all the options and highlights some of the subtleties you need to be aware of. The best part is this table in section 10.4 has a summary of all the relevant parameters used in the absolute encoder system. That section also has a convenient list of all the associated error codes. Now you might be thinking, I can already do absolute positioning in position register mode by selecting this in my paths. Why do I need all of this? The answer is, yes, you can do absolute position in position register mode, but the position won't be remembered after a power cycle, and you'll have to rehome the system. By using this, the system will be configured to take advantage of the battery backup and retain the encoder position. And yes, you can still use the incremental or relative moves when you're in the battery backed up absolute positioning mode. Now we've been looking at pulse user units, the number of pulses per revolution as set by the electronic gear ratio. And there's a whole video talking about how to set that up. You can view that 32-bit count in parameter 5.051. Just know that's not a live update. You have to write a 1 to parameter 0.49 to update parameter 0.51. Then you can read the new value in parameter 0.51. Of course, since this is a 32-bit number, you're limited to 2 billion pulses in either direction. If you exceed that, the drive will issue alarm 289. Now there is a catch. Regardless of the gear ratio, shaft rotations are limited to a 16-bit number, or 32,000 rotations in either direction. If you exceed that, you'll get an alarm 062. You can disable both of those alarms in parameter 2.070. Now you can also view the position in native pulses. the full 16 million pulses per revolution. In this mode, the number of shaft rotations is stored in parameter O.52, and the partial shaft rotation is stored in parameter O.51. So your total position would be parameter O.52 times 16 million, plus whatever partial rotation pulses are in parameter O.51. Parameter 2.70 controls whether you're using pulse user units or native pulses. Well, that ought to be enough to get you started with absolute positioning. Again, check out Chapter 10 of the user manual for all the details. Meanwhile, click here to find more SureServo2 video tutorials. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this.